Welcome to Mekco. Today we're describing one of the many benefits and features of a Mekco fiberglass building. Again, our building is being constructed to protect your investment, not only for 6 months or a year, but for the duration of time. Today we're going to focus in on the bonding of panels and how we're able to make any building of any size and configuration not only waterproof, but strong enough to handle the incoming wind loads or snow loads or whatever the challenges you may have in your respective work environment. So on this particular building, our client wished to have an R21 insulation property. What's important to mention about the Mekco buildings and all buildings that we produce is we have this integrated flange, which is unique to Mekco buildings. If you think back to why is the 2x4 in your wall configured the way that it is, it's the moment of inertia. The moment of inertia equation, as we'll depict here in a second, shows that there's an H value or a height value that's cubed. The deeper we make this flange, the stronger this building is to wind loading, snow loading, whatever it might be. So in this particular case, we have a wall that's 5 inches thick. Inside of that wall, we've embedded a 3-inch thick closed cell, 2 pound per cubic foot density foam. This insulative foam is embedded to provide that R21 value. Now that foam is enveloped in an 1/8 inch of fiberglass on the interior, an 1/8 inch of fiberglass on the exterior, followed by that gel coat. This is all rolled to be airtight. There's no air, there's no water penetration. But what's really important is that these panels are then covalently bonded together. They're not glued together, they're not adhered together, they're bonded together. They're bonded at that chemical level, creating a monolithic flange that's a 1/2 inch thick, and in this case is 5 inches deep to provide a credible moment of inertia. If we look down the building here, we'll see that towards the base, we don't have 3 inches of embedded foam, and rather we have 1 inch. And the reason we've done that is to enable access to the mounting holes or bracketry that would hold this building to the concrete pad or the steel base, what have you, in the field. If we were to carry this foam all the way through, we wouldn't have enough of a shoulder for that bolt or anchor, wedge anchor, to land upon. Now one might say, well, why not just grow the flange? We can do that. But quite often there's a pump skid or a motor control center or something inside of this space that really inhibits that flange from growing internally. So note the transition that we are able to integrate here from a 1 inch to a 3 inch of embedded foam. This being, again, an R21 insulated building.